Hello everyone. In this lecture, I shall discuss the Taylor's theorem and Maclaurin's theorem for function of two variables. Now, if we recall our previous lecture for the function of single variable, for a function of single variable y is equal to f of x, the Taylor's series expansion about the point x is equal to a is f of a plus h is fa plus h f dash a plus h square by 2 factorial f double dash a and so on, where h is a small positive number. Right, now if you put here a plus h is x, right, then here h is x minus a, and if you substitute it, then here f of x is f of a plus x minus a f dash a plus x minus a by factorial 2 f double dash a plus so on. Right, now if you want to extend it for the function of two variables f of xy, right, then what is the Taylor's theorem or the Taylor series expansion, and we will discuss it. So before the details of discussion, let me to introduce myself. I am Professor Sushant Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra Sai University of Technology, Burla, Sambalpur, Odisha. So now, without much delay, let us discuss the Taylor's and Maclaurin series expansion for function of two variables. Now, if f of xy is a function of two variables, right, and the partial derivatives are continuous, right, the partial derivatives are continuous, means here fx exists, fy exists, fxx exists, fxy exists, so on, right. So the partial derivatives are continuous. That means the partial derivatives exist here in a neighborhood of AB, in previous case single variable in the neighborhood of A, right. Then the Taylor's series expansion of f of xy about x is equal to A is given by here f of a plus h b plus k is equal to f of ab plus h del by del x plus k del by del y f of ab, right, and we may write here 1 by 1 factorial. We skip it because it is 1, then plus here 1 by 2 factorial plus here 1 by 2 factorial h del by del x plus k del by del y whole square f dash ab, okay, plus if we go on continue, sir, it is f of not f dash because we have already taken the partial derivative, okay, so it is f of ab because here we have taken f dash and here it is by default partial derivative of f with respect to x, partial derivative of f with respect to y, okay. If you go on continue, plus it will be 1 by n minus 1 factorial h del by del x plus k del by del y whole to the power n minus 1 f of, this is to the power n minus 1 f of to the power n minus 1, just a minute, f of ab. Then next the remainder term here is plus 1 by factorial n h del by del x plus k del by del y to the power n f of a plus theta h and b plus theta k, right, where 0 less than theta less than 1, right. Now this term here is for your Rn, the remainder term, this term is your Rn, this is the remainder, right, this is the remainder term. So now here h and k are H and K are small positive number, right? Small positive number, right? Very small positive number may tends to 0 here. So Rn is the remainder term here. Okay. Remainder after n terms, you say after n terms. Okay. So now you see, if x is close to a, if x is close to a and y to b, right? H and k will be very small, and Rn tends to 0 as n tends to infinity. Thus, as n tends to infinity, Rn tends to here 0. And the number of terms here, increases indefinitely. Consequently, we have an infinite series expansion of fxy in the powers of x minus a and y minus b, known as Taylor series of fxy about AB, right, which is given by about AB. Also we are substituting here this a plus h is your x, and b plus k is your y. So this implies here h is equal to x minus a and here k is equal to y minus b, right? So you substitute all these things over here. So here Taylor's theorem, now this Taylor series expansion is given by f of xy is equal to f of ab plus 1 by factorial 1 x minus a f of x ab plus y minus b f of y ab, right? Then come to the second degree term plus 1 by factorial 2 here x minus a square x minus a fxx ab plus twice x minus a into y minus b f xy ab plus here y minus b square f yi ab, and plus you continue, right? Actually we open it here, right? This whole square term we have opened it, a plus b whole square, we have opened it, right? So it is a square plus 2ab plus b square, a square plus 2ab plus b square. In that way we open it. Next term will be, we should open the whole q term, right? So in particular if your ab is equal to 0, in particular if your ab is equal to 0, then the Taylor series about origin, then the Taylor series about origin, right, also known as Maclaurin series, Maclaurin series, right? So you see, Taylor series about origin is same thing as your Maclaurin series, right? For fxy is given by here f of xy is equal to f of 0 0 plus x fx 0 0 plus y fy 0 0, right? Then for your 1 by factorial 2, next term, here it is 1 by 1 factorial, we are omitting it. The next term will be 1 by factorial 2. It is x square fxx 0 0 plus 2ab means 2xy fxy 0 0 plus y square fyy 0 0, and we continue infinitely many here, right? So you note that. So here the reminders, here the reminder after n terms will be here Rn is equal to 1 by factorial n x del by del x plus y del by del y to the power n f of theta x theta y, and here Rn tends to 0 as n tends to infinity, right? So in a remark we write it here. So usually the Taylor series are the infinite series, okay, but it is asked to find the Taylor series up to certain degree, right? So in this case, if the Taylor series of fxy is approximated to some terms up to a particular degree, then this resulting expression is called a Taylor's polynomial, okay, because it is having finite number of terms here. It is a Taylor's polynomial, right? And in fact this series are the power series, right? Now coming to one example, you are asked to expand fxy is e to the power x, your f of xy is this e to the power x cos y, and your point is the point AB is this, and you are asked to find the Taylor series expansion here. So coming to the solution, let f of xy is e to the power x cos y. So this implies my f of 1 pi by 4, it will be e to the power 1 cos pi by 4 is 1 by root 2, it is e by root 2. Then if I differentiate it, what is my fx? The derivative is e to the power x and cos y remains silent here. So implies my f of x here at this point is also my e by root 2. If I find my fy, the derivative of cos y is minus sin y, minus e to the power x sin y. So implies my fy will be sin pi by 4 is 1 by root 2. So it is minus e by root 2. Then likewise I find fxx. If I differentiate it again, then it is my e to the power x my cos y, right? So this implies my fxx at this point is also my e by root 2. Similarly, what is my fxy? If I differentiate this with respect to y here, it is minus e to the power x sin y, right? So this implies my fxy is minus e by root 2. So what is my fyy? If I differentiate with respect to y, it is minus e to the power x cos y. So this implies my f of yy will be minus e by root 2. Okay. So therefore, what is my Taylor series expansion? Thus, we have the Taylor series expansion. Taylor series expansion of fxy about AB is f of xy is equal to f of AB plus x minus a fx AB plus y minus b fy AB. Okay. then plus here 1 by 2 factorial, 1 by 2 factorial x minus a square fxx ab plus x minus a into y minus b f of xy ab plus y minus b whole square fyy ab, okay, and plus so on. Right, now you substitute all this thing here. So this implies my e to the power x cos y will be my, if I substitute all these things taking e by root 2 common, and it is my 1 plus x minus 1 minus y minus pi by 4. This is my second term here, okay, because it is e by root 2 have taken common already. Then plus the next term will be x minus 1 whole square plus 1 by factorial 2, here x minus 1 whole square into 1 minus 2ab, 2 into x minus 1 into y minus pi by 4. Then the last one is minus, so it is minus y minus pi by 4 whole square, okay. So this is my third term, and it is continued now, right, it is plus, it is continued. So this is the desired series expansion. So coming to another example, expand this means my f is this here in the power of this. So this means my a is 1 and b is my minus 3. So what is my ab here? So this implies my ab is my 1 and minus 3, right, 1 and minus 3. That means we are asked to find the Taylor series about the point 1 and minus 3, okay. So here what is the let my f of xy is xy square plus x square y, right. We may write this Taylor series in power of this, means about the point this, right. So what is here f of 1 minus 3, right, here f of 1 minus 3. So this will be here 9 minus 3 is here 6, right. Similarly you find here, you find fx, it is x square plus x, it is y square plus 2xy. Similarly you find fy, you find fxx, you find fxy, and you find fyy, and at this point 1 minus 3 you have these values. What is here fx is here 3, fy will be here minus 5, fxx will be here minus 6. So fxx, what is here fxx here, it is simply 2y, is not it, it is simply 2y, right. So similarly here fxy will be minus 4, and here fyy will be what is here fyy will be 2y, it is fy is 2xy plus x square. So fyy will be here 2x. So this is 2, okay, this is here 2. So you see here fxy is this. Now I just apply the Taylor series formula. Now just we substitute all these values here. Since it is asked up to second degree, I write up to second degree. So substituting the values, we get here function x y square plus x square y is approximated f of ab is here 6 plus here it is 3 here. So 3 times x minus 1 minus 5 times y plus 3 here, the second term, and my third term will be 1 by 2 minus 6 into x minus 1 square minus 8 into x minus 1 into y plus 3 plus here 2 times y plus 3 square. Okay, so this is the desired answer up to second degree. Let us solve one more example. Coming to the third example, obtain the Taylor series expansion of y to the power x. This is my f about the point 11 up to second degree. After this you find what is the value of 1.1 to the power 1.1. Okay, so coming to the solution here, the Taylor series expansion, we should always write it. The Taylor series expansion of fxy about AB is given by, you should first write the correct formula, or you may directly write it about f of 1 about your 1 okay, about your 1 is given by f of xy is equal to f of 1 plus x minus 1 fx 1 plus y minus 1 fy 1 then plus 1 by factorial 2 x minus 1 square fx x 1 plus 2 into x minus 1 into y minus 1 fxy 1 plus your y minus 1 square fyy 1. This is up to second degree, it is asked, up to second degree it is asked, so we leave it here. So now we substitute, we get the individual values. Now what is fx? Right, fx is, you know, the derivative of a to the power x is a to the power x ln a. Okay, so here y is my a, it is y to the power x ln y. And what is your fy? Fy, derivative of your x to the power n is nx to the power n minus 1. Okay, so here x is constant here, so here it is y x into y to the power here x minus 1, right, x minus 1. Now similarly we find our fxx, we find fyy, and we find our fxy, right. Now at the point, while the point is 1 1, so what is the value of this y to the power x? It is here 1 to the power 1 is 1. And likewise, what is the value of fx? Fx will be log 1 is 0, so it is here 0. And what is here? Fy here. Fy is putting x1 and y1, and it is 1. Similarly, we should get it. Here fxx will be 0, log 1 will be 0. Similarly, here fyy will be 0, and here fxy will be minus 1. Okay, so these are my values. So substitute all these values, right? Substituting these values, let it be my equation star. In equation star, we get here y to the power x is 1 plus y minus 1 plus 1 by factorial 2 into x minus 1 into y minus 1. Okay, because the 0 values are substituted. So now we are getting, simplifying, we are getting y plus x minus 1 into y minus 1. Okay, so now if you put x is equal to 1.1 and y is equal to 1.1, so therefore my 1.1 to the power 1.1, it will be 1.1 plus, so this is my 0.1 into 0.1, so this is 1 plus 0.11, this is 1.11. Let me to solve one more example, in fact the last example. So you see, so you are given the function f is this, e to the power x log 1 plus y in the power of x minus y. What does it mean? In the power of x minus 0 and y minus 0. What does it mean? The point is 0 0, is not it? That means it is by default the Maclaurin series or the Taylor series about origin. So from the given question we understood that it is the Taylor series about origin or the Maclaurin series. So coming to the solution here, since the expansion of fxy is needed in the powers of x minus 0 and y minus 0, thus it is the Maclaurin series of the following form. We are writing it up to third degree. So here the Maclaurin series expansion about origin up to third degree here, right? So f of 0 0, and the first term is like this. The second term is x del by del x plus y del by del y whole square. So a plus b whole square, a square 2ab b square. Then it is a plus b whole cube, a cube 3a square b 3ab square b cube, right? So it is my up to my third degree, or I write here so on dot dot dot, right? Now we get the particular values. So now let it be my equation star, say, right? So now the function and its derivatives evaluated at origin. Okay, so what is my fxy here? Fxy is e to the power x log 1 plus y, right? So at origin, putting x 0 and y 0, it is e to the power 0 1 log 1 0, so it is my 0 here. Then we find fx, the derivative, this is silent, and e to the power x log 1 plus y, it is again here 0, right? Then what is your fy here? E to the power x remains silent, the derivative of this is 1 by 1 plus y, right? Putting x 0 and y 0, it is here 1, right? Then here fxx is e to the power x log 1 plus y, and this value will be here log 1 is 0 here. Then here fxy, okay, fx with respect to y here, so it will be here e to the power x by 1 plus y, and this is your 1. Then what is your fyy? You find it is e to the power x into 1 by 1 plus y minus 1 by 1 plus y whole square, and at the 0 0 point it is here minus 1, Then come to the third derivative. Okay, your fxx is this, coming to f triple x, third derivative, it is equal to e to the power x log 1 plus y, which is 0 log 1 is 0, and f your xxy, already you have fxx with respect to y here, it is e to the power x into 1 by 1 plus y, so it is here 1. Then here fxyy, right? If you differentiate it with respect to x again, so this will give you minus e to the power x into 1 by 1 plus y square, and this value is here minus 1. And here f triple y, again differentiate with respect to y, this will give you 2e to the power x by 1 plus y whole cube. So at this point the value is 2. Now substituting these values, and considering the series up to third degree, equation star follows. You substitute all this thing here. Here e to the power x log 1 plus y, this will be y plus 1 by 2xy minus y square plus 1 by 6 3x square y minus 3xy square plus 2y cube. Okay, so this is the desired answer. So now to summarize, we have the given function of two variables must be continuous and its partial derivatives, right, first order, second order, third order, nth order, right, all are also continuous, right. This is the background. Then only we will able to expand in terms of the Taylor series expansion about the point AB. Okay, now at the moment the point AB is origin 0 0, then the Taylor series about origin is same thing as your Maclaurin series. Okay, and we have solved different varieties of examples for your easy understanding. So now if this lecture is interesting for you and is useful for you, please subscribe to this channel and also like to this channel, which will boost my motivation and it will motivate me to upload similar lectures for your benefits. Okay, so with this we should conclude this lecture here, and thank you all. Have a nice day.